Our fifth mode of inheritance is what's called multiple alleles. And multiple alleles is when you have three or more alleles for a trait. Keeping in mind that we are diploid organisms and can only inherit two alleles from our parents, even though there are multiple alleles, we can still only inherit two at a time. The classic example that we use in genetics problems from humans is the blood type allele, of which there are three. There is an A allele, there is a B allele, and there is an O allele. And we use the letter I as a placeholder to represent the trait. We're talking about immunoglobulins and the A, the B, and the O allele of those traits. So that's where the subscripts, or I'm sorry, the superscripts and the I's come from. So when we look at this situation, we can end up with a number of different possible genotypes. You can inherit two of any of those three alleles, so there's a definite number of combinations that are possible. Another situation that we have in human blood type is that the A and the B allele are both dominant over the O allele. But when we look at the A and B allele compared to one another, they are co-dominant. So having an A and a B allele means that you'll have A and B blood type, and we call that type AB blood. Having the A or the B allele by itself or with the O allele will give you whatever letter you have, A or B. So when we look at the possibilities for that, we could have IA or IAIO, and that would be type A blood. So the phenotype would be type A. We could have IB or IBIO, and that would be type B blood. We could have IAIB, which we would call type AB blood, or you could have IOIO, and that is type O blood. So we have four different blood types, six different phenotypes. I'm sorry, six different genotypes for those four phenotypes of blood type. A, B, AB, and O. Okay, so let's take a look at an example where we have a cross between a parent. Gender doesn't matter because we're not looking at a sex-linked trait, so it could be the father or the mother. Has AB blood, and the other parent is, we'll say, has type B blood, but is a carrier of the O allele. So when we would write that down, and I always recommend writing down the crosses just to help make it less confusing. We would have the one parent is IAIB, because we said they had B or AB blood, and the other parent has type B blood, so they have at least one B allele. And we said that they're a carrier of the O allele, so they would be that version of the B blood type. So that's our cross that we have set up. That's most of the hard part done. Set up our Punnett square. This parent could produce gametes that are A or B. This parent could produce gametes that are B or O. So then our offspring that we could end up with, if we look at this sex cell and this sex cell, we would have IAIB. If we look at these two, we could have IBIB. If we look at these two, we would have IAIO. And if we look at these two, we would have IBIO. So our genotypic ratio would be 1 IA IB to 1 IB IB to 1 IAIO to 1 IBIO. When we look at, so that's genotypes, genotypic ratio. If we look at the phenotypic ratio, we have to remember that both this genotype and this genotype produce the same blood type. It's called B blood type. If we look back at our first slide, B blood is either of those two. So when we write down our phenotypic ratio, we could end up with 1 IA IB to 2, whoops, I made a mistake there. So I was writing down genotypic ratios. We would have 1 type AB to 1 type A, that's this guy right here. Okay, AB would be this guy right here. And then our last one would be 2 type B's. And those are from these two, here and here. So we have 1 AB to 1 A to 2 B's. And that is how we do a cross using the mode of inheritance called multiple alleles. And most of the examples that we will do in our unit for multiple alleles will deal with human blood type. So you'll have a chance to get used to working with that notation. Multiple alleles.